Hi. Welcome back to Bridge to Success, Teradata tutorial. In this video, we will learn the creation of the secondary index subtable, and accessing the data using SI. You can view all the videos related to Teradata in the playlist of the channel, or by clicking the link mentioned in the description of this video. Secondary index. It's an alternate data access path. It allows you to access the data without having to do a full table scan. You can drop and recreate secondary indexes dynamically, as they are needed. SI require both disk space and maintenance. Whenever you create SI on the table, Teradata will create a subtable on all AMP. This subtable contains 3 columns given below. Secondary index value. Secondary index row ID, this is the hashed value of SI value. Base table row ID, this is the actual base row ID. Let's see the difference between primary index and secondary index. PI is required for a table, whereas SI is not. Primary index is used for data distribution. Secondary index can be created and dropped dynamically. SI requires separate physical structure for subtable, and requires extra processing overhead. There are 2 types of secondary indexes, unique secondary index and non-unique secondary index. A unique secondary index serves 2 purposes. Enforces uniqueness on a column or group of columns. The database will check USI to see if the values are unique. Speeds up access to a row. Let's see the steps involved to load this subtable. Here the secondary index is on column account ID. Teradata will first create the subtable on all AMP. After that, it hashes the value of this unique SI column, account ID, and based on that hashed value, it checks the hashed map for the AMP number which will hold this unique SI value in its subtable. After getting the respective AMP number, the SI value along with the 2 more attributes, secondary index row ID and base table row ID, will be stored in the subtable of that AMP. In this way, we populate our unique SI subtable on each AMP. As the SI columns is unique, there is no duplication of SI values in any subtable, means each row in the subtable is unique, and will fetch only 1 row, when we make a query on that SI column. Now, we can see how data is accessed, using unique SI when a query is submitted. We need to access the record with employee number as 33, which is the unique secondary index in the table. So, we submit a query with employee number equals 33 in the where clause. The hashing algorithm calculates the row hash value. Let's assume the value as 102. The hash map points to the AMP, containing the subtable row corresponding to the row hash value. Here the subtable is in AMP1. The subtable indicates where the base record resides. We can see that the record is in row 232 of AMP3. The message goes back over the BINIT to the AMP with the row, and the AMP accesses the data row in AMP3. The row is sent over the BINIT to the P, and the P sends the answer set onto the client application. A non-unique secondary index is usually specified to prevent full table scans, in which every row of a table is read. We can now see the steps involved to load this subtable for non-unique SI. Here the name is our non-unique secondary index. Now, Teradata will first create the subtable on all AMP. Each AMP will hold the secondary index values for their rows in the base table only. Each AMP will have the base table row ID pointer, so the AMP can retrieve it quickly if needed. If an AMP contains duplicate SI values, only one subtable row for that value is built with multiple base row IDs. We can now see how our data is accessed, using non-unique SI when a query is submitted. We need to access the record, with name as #in, which is the non-unique secondary index in the table. So, we submit a query with name equals #in in the where clause. The hashing algorithm calculates a row hash value for the non-USI. Let's assume the value as 102. All AMPs are activated to find the hash value of the non-USI in their index subtables. The AMPs, whose subtables contain that value, become the participating AMPs in this request, in this case, AMP1 and AMP3. The other AMPs discard the message. Each participating AMP locates the row IDs of the base rows, corresponding to the hash value. In this case, the base rows corresponding to hash value 102 are 232 and 376 in AMP1, and 674 in AMP3. The participating AMPs access the base table rows, which are located on the same AMP as the new size subtable. The qualifying rows are sent over the BINET to the P, and the P sends the answer set onto the client application. Thanks for watching the video. Please like and share the video. You can view more videos in the playlist of the channel, or click on the links mentioned in the description below the video name. Also, kindly subscribe the channel.